In this video, we're going to look at how to solve complex fractions with basically variables in them. So there are different schools of thought for this, but I'm going to show you my favorite way to do these. So my favorite way is to combine these two fractions into one using our cross multiply method and do the same thing for the denominator, and then we can flip and multiply. So let's see how this works out. So cross multiply method says to multiply these. 1 times x squared is x squared. Then we write the symbol in the middle, which is minus. Then we do the other diagonal, which is x times 1, so x. And we divide that by the product of the denominators. So using our exponent addition rule, we would get x to the third. And now we do the same thing for the bottom. So 4 times x is 4x. Then we have a plus sign, and then we do 9 times x squared to get 9x squared, and we divide by the product of the denominators, which again is x to the third. Now at this point we have a fraction divided by a fraction. So we could take this one, bring it to the numerator, and flip it upside down. So we have x to the third divided by 4x plus 9x squared. Okay, so now here's where things become a little bit interesting. So we have these two binomial expressions here, and then we have these monomial expressions. So, for example, we cannot simply cancel out, x squared and x third because of the parentheses, which makes that a family unit, right? So it's either all or nothing. Either we can cancel the whole thing or nothing at all. But what we can do is we can start factoring a bit. So, for example, we can factor an x out of this binomial expression here. So if we do that, we'll be left over with x minus 1, right? And if we also factor this bottom part here, we can factor out an x, and we'll be left with 4 plus 9x, right? So let's just rewrite what we have now. X times x minus 1 over x to the third. And then we have x to the third over x times 4 plus 9x. Now, the next thing that we can do is we can actually cancel these x to the thirds, right? Because this is a artificial separation. So those are definitely cancelable, and so are these x's, right? So looks like what we're left with is x minus 1 over 4 plus 9x. And notice that these are both binomials, so we should put the parentheses. And since they're not the same, that's going to be the final answer.